You don't have to write it down. Actually, pause. Turn to the back of your spiral, so you do have to write it down. Turn to the back of your spiral. Some of you need to write in order to get the unit circle, and I don't mind that. Hence why I wanted to give you a place to write it. Do 4.7 intro. Label it 4.7 intro. Remember, you looked at this just quick enough on Friday to be able to realize that you really need to know your unit circle. Which I've already told you, but I'm just trying to emphasize it. One of the biggest regrets of calculus kids, not knowing their unit circle well enough. Okay. But before we go to unit circle, one thing you were supposed to do this weekend, unit circle. The second thing was 4-6 homework. So real fast, since that's what's on the top of some of your minds as far as what you've been doing most recently. In 4-6 homework, what were the 4 things you were working on? Graphing. Who were you graphing? But you probably started by graphing who? Tangent of somebody. Cotangent. Who else? Cosecant. Who else? I'm not going to go through all the crazy transformations. I'm just trying to do a quick recap. Tangent. The original tangent. The non-transformed tangent, which gives us our really cool formulas. Tangent starts off having a point of inflection where?
Origin.
At 0, 0, which is why for our transform functions, we set whatever's on the inside equal to 0 for the point of inflection, the first one, right? Where does tangent have its first vertical asymptote? Pi over 2. Which is why for tangent, once it's transformed, we set the argument equal to pi over 2 for its first vertical asymptote. Help me out. How do we go to the next point or to the next vertical asymptote? At the period. What's the normal period for tangent? Pi. So then, when we have a V, when we have a horizontal dilation, what's that formula to help us get the period? 1 over B times pi instead of 2 pi, right? Which means if we have pi over 2 as one vertical asymptote question, where would the next, or the previous, I should say, vertical asymptote be?
Negative pi.
Good. Where would the next vertical asymptote be?
Pi.
No, because pi, wouldn't that be where the next point is? 0 plus pi. Where would the next vertical asymptote be?
3 pi.
Because we have 1/2 plus 1 is 3.5.
Look, you showed up. What are you looking at? All right, cotangent. What's different? I'm going to get my axis. Opposite.
It's split. Well, hold on, we forgot something. Tangent. What's it always doing? Always going up. Okay. Am I super picky about exactly how flat it is in the middle? Not super picky, but I should see a point of inflection, yeah? Okay. Cotangent. Let's change colors. What do you mean by split? What's at 0?
Inflection.
Not a point. Remember, it's split. What's at 0?
Oh.
What's at pi over 2? Good. But still, what's the period? Pi. So for cotangent, we flip it. We take the argument when it's transformed, bx minus c, whatever's in there. We set equal to 0 for the first vertical asymptote. We set equal to pi over 2 for the first point of inflection. Question, how do I get to the next one? The next vertical asymptote.
Add a period.
Add the period. Add pi in this case. How do I get to the next point of inflection?
Add pi to the first one.
Add pi, which if I'm going by half pi's, I would go 2 tick marks, right? And could I keep on going either direction? Sure. What do I have to remember about cotangent? Right? It's the reciprocal of tangent. Okay, those two. Done. How do we get the next two?
Draw sine, cosine.
Draw sine, cosine, and what's the clue?
Bounces off.
Bounce. There we go. Draw sine and cosine and then bounce on the other color. Here we go. Red. Which one bounces off sine?
Cosecant.
Cosecant, because cosecant equals 1 over sine. Remember your arguments. Cosecant of x equals 1 over sine of x. How high, how low does sine go? 1 and -1, what's the period of sine? 2 pi, so we're going by pi's now. But we make sine dotted, or k.
Because that's not the thing.
I need to bounce off. It's not the real graph of cosecant, it's just what I can use. It just makes things a little simpler. To get cosecant, how do you bounce?
Bounce off the max and min.
Okay, join at the maximums and minimums. I'm going to erase these points because I'm actually on it. Join at the maximums and minimums. 1/1, 1/-1 is the same. I could just start bouncing, but what do I really need to keep everything in line? And where do those occur? Where sine intersects the sinusoidal axis, or I could say where sine intersects, in this case, the x-axis, but remember that could be shifted. Now it's gotten really messy, but where's my cosecant going to go? In between. You guys remember we went to our graphing calculators on Friday, maybe it was Thursday, and we saw that the graphing calculator just shows the bounce, 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 right? Okay, secant, the only difference. Bouncing off cosine. Sine starts in the
Middle.
center or middle. Cosine starts with the, unless it's been like with a negative reflector. So then, cosine, same dealio. Period of 2 pi. I should erase that. I'm going to join again at the maximums and minimums, right? Vertical asymptotes once again are going to occur when again? When it crosses the, in this case, x-axis, but in other cases, the sinusoidal. And then, bounce, bounce, bounce. It's all because of that reciprocal nature of secant with cosine. Was that section 4.6? What was section 4.5?
Sine and cosine.
Oh, it was a sine and cosine. Did you practice that in doing cosecant and secant? Haven't we been kind of building? And what's chapter 4b with the quiz on Wednesday? 4.5, sine cosine. 4.6, and 4.7. You ready? Unit circle. Question. What is sine of 3 pi over 4? Pause. We do 30 seconds. We'll give time on this one. Sine of 3 pi over 4. What reference angle is that? 45. Good. What quadrant is that?
2.
Good. Also, sine is positive. What'd you guys get?
Square root of 2 over 2.
Second quadrant, all students, sine is positive. Sine is positive. How do you guys got it? Quick thumbs up. Little baby one. Oh, how many of you guys got something different? Thumbs down.
Come down.
How many of you guys were just off by a sign?
No.
The rest of you guys, okay, maybe we need to practice a little more. Okay? Let's do a speed once. Ready? Sine of,
No.
let's do cosine of. Cosine of 7 pi over 6.
Negative square root of 3 over 2.
You guys agree?
Yeah.
What quadrant was that in, Ricky?
3.
So cosine was negative. What reference angle is that?
30.
30 degrees. If you're a visual person, go over or back a lot. Square root of 3 over 2, but negative. If you're in your chart, your table test, not table test, sorry, that's calculus. If you were in your cheater table, cosine is the second one, right? And that's at 30 degrees, so be over. 3, 2, 1, right? It's the second one. 3, 2, 1, so it's a 3. Square root of 3 over 2, but negative. How about tangent of negative? Ooh. Take some time. Take 30 seconds. Tangent of negative pi over 3. Oh, that's 4 quadrants. Bless you. I'm going to draw this one out just for sake of illustration.
You guys get these as 60? Does that help? So square root of 3 over 3, 1 square root of. Square root of 3, but in the fourth quadrant, so. Maybe square root. If you don't use the table, that whole little song doesn't mean much. But hopefully you have another way. You've spent a long time on unit circle, right? A way that works for you. Triangles. Straight memorizing. Some of you are like, if I could have just had 2 minutes to begin, I would have drawn the whole thing and I would have been fine. That's cool. I don't know, right? Can you draw the whole thing for yourself on the quiz on Wednesday? Yeah. Can you make the whole table? Yeah. You do you, okay? Okay. Why do we need that? For this stuff. For this stuff. Alright, back to notes. Thanks guys for making your spiral up. Let's go back to notes. We talked about on Friday, inverse. Some of you have been trying to use this little button for cosecant. But it doesn't work because this is not sine to the negative first power. What is it? Inverse of sine. We're undoing sine in some ways. We're going backwards in other ways. But what we noticed first off on Friday was that if we just flipped the graph of sine, we're in big trouble because this green one is not a what? It's not a function. So we cut it down. So inverse sine, the function inverse sine, which I would write as, I can name it a function now that I've cut it down. And if you were to graph it in your calculator, and I think homework 4.7 kind of had you do this, it would cut down sine inverse. It would only show you that piece, even though it's kind of built off of the whole sine sneaking around the y-axis. What we notice, we have to cut this puppy down, and what that actually applies, or how that applies, is that sine inverse answers, what comes out of a sine inverse function, are only going to be the angles, negative pi over 2 to pi over 2. And guys, if you think better in degrees, that's okay. What would these degrees be? Not 45, that's pi over 4. Negative 90 to 90. You need to think about it that way. It's negative 90 to 90. So does my picture over here make sense as to what quadrants we'll be looking at? We'll just be looking at quadrants 1 and 4. But even to get in 4, we can't go the positive direction. We can't go around to like 11 pi over 6 or 5 pi over 3. We can't go around this way. We have to just go positive pi over 2 and negative pi over 2. That's why I showed you that negative pi over 3 for tangent in our example. And then I was able to have enough time to show you one quick example, maybe two, I forget. There might be another example on the next page. To show you one quick example of sine inverse goes backwards. Instead of you guys having an angle like we just did, having an angle and finding a ratio, sine inverse says, no, inverse functions, x's, y's switch. So you're given, who is this? A ratio. You're given a ratio. You're given a y value in the unit circle that you guys have in your notes back in section 4.2, something like that. You're given the answer of an old sine problem, and you need to find, who is this right here? I know it's in the first quadrant, I know it's 30 degrees, but what would be the label for it? Not a ratio, but an radian, which means an angle. Yeah? So you're given a ratio, you're going to find an angle, but we need to develop that a little bit more. We did one more example really quickly. But once again, can you guys tell you're being given a ratio? And more specifically, if we were doing like with triangles, it would be a SOHCAHTOA, an opposite over hypotenuse, right? You're being given the answer. You're being given the y value for a sine function, and you're trying to figure out what's the legal angle that corresponds. Okay, let's talk about sine for a second. Inverse sine function.
Our goal today is to get to inverse sine, inverse cosine, inverse tangent. We're still going to have a little bit more time tomorrow, but we need to check our homework tomorrow too. But some of you guys did kind of get a little grace to finish that 4-6, and others that might have needed. They want at least do a little bit of 4-7 too, yeah? There are two different ways of writing inverse sine, and guys, trust me, they mean the exact same thing for our purposes. Other books define it a little bit differently, but for our purposes, we're going to say they are two different notations for the exact same thing. Sine inverse, which you're used to, and then arc sine. Think of it this way. If you were like typing and you were trying to explain sine inverse, sine to the -1 is going to be a little rough, and you're going to probably use like a little caret, which means power, so it gets confusing. But if you type arc sine, really easy, don't have to do any little caret, and it doesn't get confusing. So for right now, without going into tons of depth, we'll just say they're synonyms, okay? Mean the same thing. But that's only true if and only if sine of y equals x. Please do you. Remember? In all those unit circle examples we just did, you were given an angle. Old-fashioned. Sine like you've been learning since geometry. You're given an angle. Maybe in degrees, maybe in radians, and you find what we would say is a value, but technically it stands for trigonometrically a ratio. Opposite of the hypotenuse. You're given a degrees or radians. You're trying to find the corresponding sine value, but that's for normal sine. For inverse sine, it's going to flip. So you're going to be finding the angle in degrees or radians. Just depends. Sometimes they'll tell you. Sometimes both answers will be appropriate or okay or acceptable. You're finding an angle given a ratio. Remember, you know your unit circle so well you can go backwards. This notation means the exact same thing. You're finding an angle given a ratio. Okay? So let's do a couple more examples. You guys saw a couple on Friday. Let's do a couple more. One quick last note. Cosecant equals 1 over sine, which does not equal cosecant is 1 over sine. 1 over sine is not. 1 over sine is not sine inverse, right? Which is why some of you guys have been making that mistake of using this button in your calculator to find him, and it's not true. Okay? So wait, is that true? Good. Okay, here we go. One more time. We have to remember where we're allowed to be looking for our answers, which is only in between -pi/2 to pi/2. And if some of you visual people need it, I'm kind of visual too. We're only looking here and here for our answers for the following three, okay? What kind of angle would give me a sine answer of 1/2? 30 degrees. Your little table, if that's you, 1/2 comes right at the beginning, 0 to 30. If you're a visual person, if you're a visual person, up a little would be a 30 degree. But wait, 30 degree, hold on, is that an over 6 and over 4 and over 3? Over 6 is a small slice of our calzone, right? Or I should say a pie. Am I going first quadrant?
No.
Or fourth quadrant? If I have to choose, why am I going for it? So I'm going to have -30 or -pi/6. I'm going to put both because depending on the problem, either one's okay. If they don't tell you radians or degrees, well fine, I'll just do whichever one I want. Stick it to the man, sounds good. Now if it was a multiple choice on a quiz or a test, well, wouldn't we have to look at the answers and see if they have degree marks or not? If they have degree, we better give them a degree answer. If they don't have degrees, we better do radians.
Question. Where does sine have a value of root 3 over 2? 60. Is that going to be quadrant 1, 60, or quadrant 4, 60?
1.
Good. So we could say 60 degrees, or, come on, my amazing radian people. Pi over 3. Yeah, remember, we're given the square root of 3 over 2. We're giving the angle pi over 3. Okay, cool. Whew, we're on a roll. And some of you are just starting to get the hang of it. Others, hang in there. Let's see if it clicks. In the unit circle, look at your table. Where is there a 2? Ninety is the highest sine goes, and how high is sine at 90? Does sine go again? Not without being transformed. Well, this isn't asking for transform. So is sine allowed to be 2? Calculate it out. Doesn't matter what mode you're in. I don't care. Just put in second sine 2. Our minds are like, wait, what? It doesn't work. Not saying our calculators are absolute truth. Let's see if they back us up. Sine inverse, second sine of 2. Not infallible. Can't even show holes unless we tell it to. What's it say? Ah, guess what?
Undefined.
Doesn't work.
It's always
Doesn't work. Wait. Remember sine inverse? Didn't we say the answers have to be between negative pi over 2 and pi over 2? Did you guys forget? There's also a restriction for what can come into sine inverse. So question, what if I was to ask you sine inverse of 3?
No.
Sine inverse of 1.1? Sine inverse of negative 1.01? Doesn't matter. Anything outside 1 and negative 1, error does not exist. Okay, do you have your calculators out? Anyway, real quickly, sine inverse of 0.265. That is not a unit circle problem. We could not exactly, we could maybe approximate,
Plug it in.
but exactly we wouldn't be able to solve. And what'd you get? Yeah, plug it in. This is the plug-in type. 0.28. Someone back them up. Anybody else get 0.28? 0.268? Sure, that's not very helpful. Okay, they get a different answer though. There's 2 different possible answers, radians and degrees. Look, this is what you get. Ooh. What does that sound like?
Degree.
Right? Lucas, help me out. 15.1? 368? Radians or degrees? You guys back them both up? We're good? Okay, let's keep going. You gotta get through cosine and tangent. But you guys got the idea of sine. Isn't that how we did graphing too, though? We started with sine, then we built on it? You suppose. Okay. We're not going to spend tons of time and go into as much depth, because frankly, we've already introduced it. So let's just see what changes when we have. Is that a little better? There we go. When we have cosine and tangent. Cosine. Starts at the top. Right? Okay. If we were to flip him, now the units are a little different. Remember the x for cosine measures in angles, the y measures in ratios. Well, long story short, roughly you go out. Good struggle. Is that a function?
No.
Stink. So what has to be true for cosine too?
Let's restrict the
We need to restrict him, but remember how cosine is sine shifted? He's not going to be the same as sine because he's shifted, right? So he's going to have a different legal range. He's still going to go domain. He's still going to only be able to take in values between negative 1 and 1. For the same reason that sine inverse couldn't take anything beyond 1, anything less than negative 1. It's impossible if you think of geometry. If sine is opposite over hypotenuse, hypotenuse has to be the biggest side, the biggest number. The denominator is always biggest, or at least, or at most equal to. That's the same, but what's different? Cosine, yeah, only going to go between 0 and pi. Which, if I was thinking unit circle, my visual people, it's
different. I'm allowed to look in quadrants 1 and 2, between 0 and 180, if you're more of a degree person. Cosine to sine shifted, so he's not going to have the same legal values. Tangent, remember he repeats too. If I was to flip him, well, this gets really yucky. But the idea, see if you guys can follow it. He has to flip across the y equals x, right? Like any inverse? But if I kept graphing them, question, see a function either? But what if I restrict them?
How did that one really? The cosine doesn't get reflects over the x equals y equals x.
It's because the units are a little off. If I'm going by pies, that's 3.14 instead of 1, so the units are off. But do you notice, like, you go up and you go right?
Yeah.
And then you curl around. So it works, just the units. Yeah, I won't about that. So inverse tangent, only one cycle of tangent, but the cool thing is it's the entire cycle as opposed to sine and cosine. But it's still important that we restrict him. And so his domain, ironically, not ironically, you know tangent goes forever low, forever high. So just to apply it, he's allowed to take anything. You can plug in any stinking number, however big, positively or negatively. And he'll be fine. He's never going to have an error, but he's similar to sine inverse, only allowed to go between negative pi over 2 and pi over 2. But question, why is that open? HLT was why we had to cut down the original tangent, but why open? Why not closed? What's going on at those two? No, you can't touch them because they're vertical asymptotes. For my degree people, that would be between negative 90 and 90, right? For my visual unit circle-y people, don't you dare pack up my little stinkers. We're still going fourth quadrant, first quadrant. Fourth quadrant, first quadrant. So we're just going to end with, I think I have a whole nother minute, a couple examples. What if I was to give you cosine inverse of square root of 2 over 2? Cosine inverse of negative 1/2. Question, where in the unit circle for cosine inverse you're only allowed to go between 0 and 180? 45 degrees. First quadrant or second quadrant?
First quadrant.
First quadrant. So that would be 45 degrees or? Where does cosine match up with 1/2? 60, but in the first quadrant or second? Second, because I need it to be, so it's going to be 120 or 3, no. What's the 60 degree in the second quadrant? What is your goal today for tomorrow? Finish up 4-6 if you haven't yet. It should already be done. Test corrections, step 4-7, fine. I'll be here after school until about 5-ish. Test corrections are due tomorrow by the end of the day. If you come in at lunch or after school, I'll be here. You guys need sheets.
I don't know if I got one
As I
or not,
take
but I'm not gonna
out.
grab one.
Take a sheet if you need one. Go to the bathroom, not in the chapel. Just kidding, don't trample anyone.
I want to ask a
Yeah.
sexual test one.